All right, let me go ahead and share my screen here. And I believe we left off our ggplot lecture at this section, starting from scratch, and we'll go into basically how to make some ggplot graphics. Okay. Prior to this, if it's been a little while or you forgot, the key idea with the grammar of graphics was that we are taking aspects of the data and we are mapping them to visual properties. So we're taking, in the data, the variable height, and we are mapping it to the X position. We take the variable weight, we map it to the Y position. We take the gender and we map it to the color. We take the hair color and we map it to the shape of the point. All right. Okay, so let's go ahead and talk about creating a graphic from scratch. All right, so here is our just toy data set again. We have 6 data points, 6 rows, and we have 4 columns. Each column is its own variable. So this is ggplot's part of the tidyverse, and so our data needs to be in tidy form. Okay, and so when we create a graphic, okay, we just start by saying ggplot, okay? We just call ggplot. We put in the name of the data frame. In our case, our data frame is just called df. We put in the name of the data frame, and then we give it some basic aesthetic mappings as far as, maybe where the X and the Y, what those will be mapped to. Okay, so we say AES for aesthetic mappings, and we're going to say the height variable gets mapped to the X position. The weight variable is going to get mapped to the Y position. Okay. Now, when you call ggplot all by itself without any geometric objects, it's going to just produce this blank empty plot. Okay, this is a blank empty plot. This is a graph without any geometric objects. Right. And so so here, what ggplot does is it takes that information, X equals height, maps the height column to the X position, X equals weight, gets mapped to the Y position, and it also figures out kind of the limits of the axes and things like that. Okay, but ggplot doesn't know if we want bars, lines, points, or some other kind of geometric object. All right, and so what we need to do is we need to tell it the geometric object to point plot. All right, so we're going to add geom_points, and what ggplot will do is then it's going to add points for our data values. Okay, and so this will result in a scatter plot. Okay, so this is the same command as before. ggplot df aesthetic mappings, height goes to X, weight goes to Y, and we're going to add points. And there were 6 rows in our data set, and so we have 6 dots plotted in our scatter plot. Okay, and that's the basic scatter plot here. If we want, we can add an additional aesthetic mapping. Okay, and so well, actually, before I get to that, what we can do is we can take this result of ggplot and store it into an object P, and then later we can do P plus geom_point. Okay, this command here, now that I've stored this into P for plot plus geom_point is exactly equivalent to this, right? Because this P represents this part, and we're going to have plus geom_point. All right, and inside geom_point, I can add another aesthetic mapping, and here I'm going to say the variable gender is going to get mapped to the color of the point. Variable gender gets mapped to the color of the point. So I'm going to just put the AES call inside geom_point. And when I do that, indeed, it adds color. All right, and it says M is going to get represented by these teal dots. F is going to be represented by this pink or salmon color. And so here are our 6 data points. Okay. There are also attributes known as settings. Okay, a setting is different from an aesthetic mapping, okay? An aesthetic mapping takes a property of the variable, so one of the columns, and properties of the data, so one of the columns or variables is going to get mapped to an aesthetic attribute. So, so if the gender is this, it's going to get mapped to this color. If the gender is something else, it's going to map to this color. If the gender is something else, it's going to get mapped to another color. With a setting, we're just going to kind of apply this value, a setting, to all of the data points, okay? And the settings are not influenced by the attributes of the data, but it's just something that we're going to apply to kind of this graphic. So here we're going to say color equals blue, and this is going to cause all of the data points to be plotted with a blue color. Okay, it's not tied to an aspect of the data. Here we're going to say size equals 10. This is just going to be size 10 for all the data points. It has nothing to do with any of the actual data values. All right. So here, all of the points are blue and the size is 10. No data information is being conveyed by a setting. Okay. Here, we're not going to gain any information by looking at this. We're not going to be able to tell anything about the data other than the height and the weight. Okay. We have no information about the hair color, no information about the gender when we look at it using a setting. Okay. The setting is just used for kind of visual properties to kind of just make your plot a little bit nicer. Right. So you can also change the scales of the graphic. Okay. So one thing we can do is we can modify the X limits, okay, of the plot. So ggplot automatically kind of determines, kind of based on the smallest and largest points, where the axis limits go. But what I can do is I can say the limits, I want to set them to be 60, 100, okay? The largest data point we have is maybe like 72. But if I say I want the x-axis to go from 60 to 100, okay, setting scale x continuous, then I can do that. The lower point is now 60, and the largest point over here is now 100, okay? And so all it does is it rescales the graphic, all right? Now, I'm not expecting anybody to remember this. I can never remember this. And so all of this is always done just by kind of going onto the internet and you type in ggplot change x limits, all right? And usually one of the first hits will be the ggplot reference, okay? You're gonna see other, when you do a search, you'll probably see other websites, right? I highly recommend try to find the one that says tidyverse.org. This will be the official documentation. This is where you're gonna find kind of the information. So here you can actually just do xlim, and I think, okay, well, there's different multiple ways of doing similar tasks here, okay? But here we can do scale x continuous, and along with other attributes, you can always pull that up. Okay. Another thing, okay, so not just changing the kind of the limits of the x-axis counts as altering the scale, but changing the color attributes is also known as changing the scale, okay? And so you can do a scale color manual, and here we can say, you know what, for the gender, okay, which the default colors are kind of that teal and, you know, pink salmon color, you can say, you know what, I want to use different colors, right? And so here we can say, I want to use orange and forest green, right? So notice what I'm doing here, right? So here I'm going to take P, which is kind of, which we defined way back here, is just the aesthetic mapping of X and Y, height and weight to X and Y. And here we're going to say, let's add points. We're going to map the gender variable to the color aesthetic. Okay, so we're going to map gender to color. We're going to use a setting. We're going to set all of the dots to be size 10. So no information is going to be gained from the size of the point. All the points will be the same size. But here we're going to manually set the color values. We're going to say we want to use orange and forest green, right? And so when we do that, this is what our plot is going to look like. So this is the plot. And here I've taken all of this, okay? And I'm going to save this as P2, all right? And so P2 is now this object, and I can call print P2, and it's going to print like this, right? And so this information has height, weight, and gender displayed here. We don't have hair color displayed on here, all right? But by looking at the colors of the dots, we can figure out the gender. By looking at the X and the Y positions, we can figure out the height and the weight. There are a few things you can alter. There's something called a theme, okay? And with themes, you can change the kind of the colors. So the default is to have this gray background with white guidelines. But you can use, if you're printing any of these plots, I think people find it annoying to have to print, a bunch of gray. So you can use theme black and white, and you'll have kind of a white background with gray grid lines and things like that. There's several different themes. There's like a high contrast theme, a dark theme, and you can go on the ggplot documentation to find more information about themes. Here, when I talk about printing, I'm not talking about printing on a printer. I'm talking about just printing to the display. And when you use base graphics in R, the function, the plot function tells R to draw graphics to the output device, okay? And the output device is usually your screen. Sometimes you can say output to a file or a PDF or something like that, okay? With ggplot, the command doesn't directly draw to the output device, okay? Instead, the command, the ggplot command, builds a plot object, right? And the graphs aren't drawn until you call the print function, right? As in you call print on the object, right? And for a lot of these things, we've hardly asked. I didn't say print here, okay, but it plotted it out, right? And that's because R's default behavior is that when it returns an object, the default behavior is to print that object out, right? You run a function, you say, what's the sum of 1 through 5, and it returns that sum 15, and the default action is to print it out, okay? And so here, what's happening is when we call ggplot, R returns an object, and its default action is to print out that object, okay? But if you are running a script, okay, running a script or some kind of loop, then it's not going to be outputting these things onto the screen. It's not going to be printing these out. And so if you want something to be output from within a script or a loop, you're going to have to explicitly call print on the object that is being produced, okay? So the behavior at the interactive prompt is different, and so you're going to have to call print on the object. Okay. There are some cases where you need to kind of transform or summarize your data before it gets mapped to an aesthetic, right? So for example, if I told you to make a histogram out of a table of data, you can't just look directly at that data and make a histogram. You first have to create some summary statistics or summary values. You have to go through the table and you have to kind of bin them. And you say, this is how many values fit between 0 and 5. And this is how many values fit between 6 and 10 and 11 through 15 and so on and so forth. And you'd have to kind of create bins. And once you create bins, then you can basically turn it into a histogram by making bars, right? And so this is called kind of just summarizing our data. And so, ggplot allows us to create histograms by, calling something like geom_histogram. But basically what it's doing is it's performing some stats functions, okay? And ggplot comes with a variety of stats functions. So if you go to under the different reference objects, okay, you can kind of create there's different stat functions that can be done to do this, okay? So there's a lot with ggplot. There's a lot you can do, and you know, we're just going to cover some of the basics here. But yeah, my recommendation is when you try to do anything, you know, just start off at the kind of the reference manual, see if any of these geometric objects seem like something that you want to do, or see if any of these kind of stat functions will enable what it is that you want to do. All right, so just kind of in this beginner thing, we're going to look at some of the most basic geometric objects, which will be the bars, lines, and points. Okay, so you can make scatter plots, you know, line graphs and bar plots. And so, you know, I'll start there and then point you to kind of the reference manual for anything else. All right, so so all of these have their own reference things, and then other ones that are probably useful are the histogram and the box plot. But as far as we're going to look at in our class, we'll just look at the point, the line, and the bar. Okay, the full list of geometric objects is available in the kind of the reference manual under layers geomes. Okay, and you can see there's all sorts of things. You know, a two-dimensional bin count, kind of like a. This is like a histogram, but using color. Okay, so it's a heat map, I guess. All right, and then you can have, you know, densities and dot plots and hex plots and things like that. Okay, and then there's also a nice cheat sheet that I recommend. This is the official one from RStudio for ggplot. Okay, let's start by taking a look at some bar graphs. Okay, and so as far as a bar graph goes, okay, we're going to have one column, okay, and it could be a categorical or numeric value, represent the x position of each bar, and then another column, and that one has to be numeric, is going to represent the height of each bar, okay? And so, so we're going to say, you know, we've got the control group. This bar should have a height of 5.032. The treatment group will have a height of 4.66. Treatment group 2 will have a height of 5.52. Okay. We're going to use geom bar, and we're going to have to say stat equals identity. And this tells us to use just the value itself, the identity of the value itself. The default behavior of geom underscore bar is to kind of do some summary stats, to go through a column and kind of tally up how many times it observes something. But here we're going to say, you know, the number that represents exactly how tall we want it is stored in there. Okay, and so here it is. Okay, so notice the command is much like we've had before. We're going to say the group variable, okay, control treatment, treatment 1, treatment 2 is going to go on the x-axis. And so we have 3 positions: control, treatment 1, treatment 2 on the x-axis. And here we have the height. I'm sorry, the height of the bar being determined by the weight variable. So we're going to say weight gets mapped to the y-axis, right? And we say geom bar stat equals identity, and there's our plot. All right, here's a slightly larger data set. Okay, here I have 2 cultivars, and we've got measurements on 3 different dates. Okay, we have cultivar 39 and cultivar 52. This is apparently some kind of cabbage data set, and I'm not quite sure what's being recorded here, but we said, you know, on day 16, the weight was 3.18, day 20, 2.8, day 21, 2.74. So I don't know, maybe this, I'm not quite sure. And then, you know, we have standard deviations and standard errors and things like that. Okay, and we have all of this. Okay, so imagine what this plot is going to look like. We're going to take the date, and we're going to put that on the x-axis, right? So on the x-axis, we're going to have 3 locations. We're going to have a location for D16, D20, and D21. We're going to take the weight, and that's going to go on the vertical axis, the y-axis. The weight will have different heights for the weight. And fill, with a bar plot, the color that fills in the bar is known as the fill. Okay, so this is going to be the fill color. And so we're going to have 2 colors, one color for cultivar 39, one color for cultivar 52. Okay, and as far as the to make them a side-by-side thing, we're going to say position equals dodge. Position equals dodge means don't stack them on top of each other, but put them side by side. We're going to kind of dodge the x positions. Okay, and then as far as the height of the bars, we're going to use the identity. Okay, and so these are the only 3 variables that are being plotted. We're not going to see any information about the standard deviation, sample size, or standard error. Okay, this is not. We aren't mapping any of those variables to the aesthetic attributes, so this information is lost in our plot. Okay, and so here we have it. All right, 3 locations for the date, D16, D20, D21, 2 colors for the cultivar, and the height of the bars correspond to the weight. Okay, so that's that creates a side-by-side bar plot, assuming the values are stored in here. Okay, here is here's another data set. This is a very large data set. This is the diamonds data set. It's got around 53,900 entries, rows in it. And this is just kind of the first 6 rows. And what we're going to do is we're going to take a look at this variable cut. Okay. And so if you don't specify stat equals identity, the default behavior of geom bar is to kind of go through a categorical value and tally them up and plot how create a bar whose height corresponds to how many values it saw. Okay, so here we're going to say ggplot diamonds. Okay, and here x is equal to cut. All right, we're only mapping the attribute, the x attribute. Okay, I'm sorry, the cut variable to the x-axis. So the cuts can be fair, good, very good, premium, and ideal cut. Right, and we didn't map. Notice there's no mapping for y. Okay, y is count, and we can't map count because there's no variable called count in our data set. Count is something that we've derived by having the computer kind of go through this variable cut and count how many times it sees ideal, how many times it sees premium. And so the count is something that's direct. It's not an aesthetic mapping. And that's the default behavior of geom_bar. Over back in these things, we had a variable weight that we wanted to map to the y-axis, and that's why we have weight equal to y in the aesthetic mapping. Over here, there's no count variable, right? And so there's nothing to map to the y-axis here. All right, I hope that makes sense. All right, here's another data set. Okay, and so this is the U.S. population change. Here we're going to just kind of take the I think this is from the 2000 to 2010 census. I'm not 100% sure. And then, we recently had the 2020 census, but that data hasn't been published yet. And so anyway, this is kind of like which states had the greatest growth, okay? Which ones grew the most? And we're taking kind of the top 10, all right? So when you rank them, the smallest is 1 and the largest is going to be 50. And so I think Nevada had the greatest population change. It grew 35% in those 10 years. And okay, so anyway, this is our data set. We have Arizona, we have the state, the abbreviation, the region. And so pretty much all the growing states are in the west or the south. And then this is the percent change. All right, and so here is what we produce in our plot. we're going to say along the X, we're going to put the abbreviation, right? And so this just goes in alphabetical order right now. Arizona, Colorado, Florida, Georgia, et cetera, et cetera. We're going to say the height, the Y is going to be this variable change. Okay, so we're going to say change equals Y. And again, we use stat equals identity to say that, you know, the exact height of the bar. And here we've got two regions here. We've got south and west, and we're going to map that to the fill color, the aesthetic color. All right, so this is our aesthetic mapping. So these three variables are plotted, and here is our bar plot. All right, we can customize a few things. All right, and so here I'm gonna I need to change the title here, but I'm gonna take the same variable change, okay, and I'm gonna also map it to the fill color. All right, and so so now there's only two, like we've lost this region information. Okay, there's only the same variable is shown aesthetically in two different ways. Okay, one, we can see the height, and then the other, the light versus dark also carries the exact same information. Why would we want to do something like this? Okay, well, sometimes you really want to emphasize a particular variable, and you might want to try to express that information multiple ways to kind of drive home the point. And so, you know, what we might, you know, Nevada is, you know, much taller than everyone else. What also becomes clear here is that it is much brighter than all of the other colors. And so we're kind of bringing a little extra attention to the fact that, you know, this bar is much taller than everyone else. Okay. Here, I've reordered. I've taken the exact same information, okay, and I've reordered the states based on their change. Okay. So here we've taken this plot and we've just rearranged them from shortest to tallest. Okay. So we said reorder the abbreviations based on change. Okay. So the X is still the abbreviations, but we have reordered them based on the change variable. Okay. And then you know, Y still carries the height information, and then the fill is based on that. And so now this is quite, I think, quite pronounced. We can see, all right, there seems to be kind of the change, you know, the difference between these are, you know, almost like on a smooth gradient. Okay, we can almost see this smooth line here, and then suddenly there's a huge jump here, and it's noticeable in not just the height of the bars, but also the color of the bars themselves. This is just if you wanted to alter the colors. So here I picked UCLA's colors, and this is just, so here we're going back to choosing the fill color based on region, and we have the South and the West, and I've chosen these yellow and blue colors for that. Okay, and that's just altering the scale color. Or here we can say, you know what, let's go back to using the numeric variable, the continuous variable change, and use that for the fill color. And here we can change the what the low and the high is. Low is going to be red, high is blue. And again, there's kind of a nice smooth gradient from red to kind of this magenta purple color, but then there's quite a stark jump to go from, you know, this is around 25 to around 35. There's quite a big jump there. Okay, so that's that for bar plots. Let's go ahead and take a look at some line graphs. Okay, so here, line graphs, I've got just two variables, time, demand. Okay, we're going to put time 1, 2, 3, 4, 5, 7 on the x-axis, and demand on the y-axis. And we're going to just do geom_line. So it's a lot like geom_point, except geom_line is going to kind of connect them with a line. And this is what we have. Okay. So, 1, 8.3, 2, 10.3, 3, 19.0, so on and so forth. So we just have this and it plots that. So it's basically dots, but it's connected with a line. Okay. Here I've got another data set. Here we have 3 variables. Okay. One is a factor. And this, I think, was, I'm not sure what this data is and who ran this experiment, but apparently we looked at guinea pigs and we looked at the teeth on guinea pigs. We gave some of them orange juice. Other guinea pigs, we gave them vitamin C, and we wanted to see, how much their teeth grew. Okay. And so, so here we've taken the tooth growth data and I've used some dplyr information and we've grouped it by the supplement type, either orange juice or vitamin C. The dosage, we had different size dosages, one, half of whatever, half of this, 1 or 2, okay? Different size dosages. And then we're gonna look at the mean, okay? Mean of the length variable. All right, and so we've got these things and we wanna kind of plot them. So, this information can be plotted with dots, they could be plotted with bar plots, or they can be plotted with lines, okay? So here we're gonna use lines to plot them. And this is what it looks like. We're gonna take the dose, and that's gonna go on the x-axis. So our doses are 0.5, 1, and 2.0, right? And we're treating this numerically, okay? So that the distance between 0.5 and 1 is half the distance from 1 to 2, right? And that may or may not be the choice that someone else wants to plot. Okay, we're gonna take the length of, I guess, their tooth and put that on the y-axis. Okay, and so we can see, we got 26.1, both for level 2, but the difference between the low doses of vitamin C versus the low doses of orange juice, there's a difference there. Okay, and then the color of the line is going to be the supplement type. Okay, so we're going to get orange juice gets the orange color, vitamin C gets the blue color, the teal color. Right, and so there you have the 3 variables being plotted here. So we're going to put the supplement type to the color. Now, if you're printing these, okay, and you don't have a color printer, you can use something. You can take the supplement and you can map it to a different aesthetic attribute, like line type. And so with line type, you can have solid lines and dotted lines. And I think there's several different kinds of line types. There's like a dashed dot and a dashed and things like that. At a certain point, it gets difficult to see. But the difference between a solid line and a dashed line or dotted line is quite easy to notice. And so for a few amount of categories, changing the line type, I think, is fine. All right, okay, let's take a look at scatter plots. I think we've already seen a lot of this stuff from scatter plots when we did kind of building our thing from scratch. So I'm gonna just kind of go through this a little bit quickly. All right, so here your general scatter plot, you've got an X variable and a Y variable, okay? One numeric variable goes to the X axis, another numeric variable goes to the Y axis, and you just add points. All right, so we're gonna say this is someone's age in years. This is heights of, I guess, different children from ages 12 through 17, and we're looking at their heights, and we can see people growing from 12 through 14. Maybe it kind of levels off a little bit over here. You can change a few aspects. Shape as a setting, so I can just say, I want all the shapes to be shape 21, and there's kind of a listing of shapes. You can always go and type in R graphic shapes. No, that's not what we want. I'm sorry, R plot shapes. Okay, that's what I meant, what we want, right? So we've got the plot symbols, you've got different things available here. Here I'm changing the size of the points. Okay, so I'm making them bigger as a setting. We're going to map the sex attribute from our data set to the color. All right, and so now we can see we have blue dots and red dots, or teal and salmon. And, you know, maybe they're quite mixed over here. And then as people reach older ages, you know, there seems to be a little bit more distinction between the heights of males and females in our data set. If you don't want to use plots, you can use the shape of the point, okay? Now this is, in my opinion, a lot harder to see, okay? We've got circles and we've got triangles, and you can manually set the kind of that attribute. You have to kind of look up how to manually set which shapes to use, but it can be done. You know, I think this is a little bit harder to see than the colors, right? Okay, and lastly, I want to just show you how to plot information for multiple data frames. All right, and so sometimes you'll have different data sets or different bits of information, and you want to plot them. Okay, and so so you can create different data frames. All right, and basically, when you add a geometry, you can specify the data, which data frame that information is coming from. All right, so first I'm going to just create kind of a sequence from 0 to 6, and we're going to plot, here I wrote sine, but we're going to actually plot the cosine. Okay, we're going to plot the cosine of x. So we're going to plot the cosine of x starting at 0, going to 6, so a little bit shy of 2 pi. Okay, and so here, you know, I didn't have to write a loop, okay, but just we're going to just plot x and f of x, right? So this is meant for kind of any kind of function, but we're going to take this and plot all of this. So here I'm going to just say, let's take our function data, which is this data frame. We're going to take x and map it to the x-axis fx, okay, which is basically cosine of x, and we're going to map that to the y-axis. And we're going to set the color equal to blue. This is a setting. The size equals 1. That's a setting. No information is going to come from this. It's just here for visual properties. And so there's the plot of the cosine, right? Starts off at 1, dips down, comes back up, and we're almost to 2 pi. And so we're just a little bit shy of 1 there. All right, let's say I wanted to add data points, okay? So here I have a separate data frame. This data frame is called df_points. This is a different data set. And let's say I want to combine this information to this plot. So this is my plot of the cosine function. Here I've got just some x and y points, all right? So x is just going to be a sequence going from 0 to 6, and y starts off at -0.5 and increments by 0.1, okay? So not all that interesting, but this is how we're going to plot it. We're going to take plot P, which we've established back here. This is plot P, and this is what plot P looks like. And I'm going to say take plot P and add the geom points where x is the x-axis. It gets mapped to the x-axis. Y gets mapped to the y-axis. You know, if you had different names here, you would map those names accordingly. And here, this is where we specify that this data doesn't come from the same data set, but this data comes from this data set here, this data frame, df_points. All right, and so when I do that, here are my dots, okay, going from 0 to 6, incremented by 0.1. So here I've got basically two things. And if I want to add another data frame with more points, same type of thing. You would just call plus geom point, and you can start it. So now I've kind of updated my plot P to include the geom points, right? So this is what plot P looks like. And if we want to add more, so here I'm going to add some line segments. And so to plot segments with ggplot, you need to specify the x and y coordinate of the starting position and the x and y coordinate of the ending position. So you've got x1, y1, and you have x2, y2. And so here I'm going to have a data frame consisting of the various columns x1, y1, x2, y2. All right. My x1 is just going to be a sequence starting at 1.25 by 0.5. And so I go from 1.25, 1.75, 2.25. And I'm going to make vertical sequence segments. All right. So my x1 and x2, my starting x is going to be the same here and here. And then as far as y goes, I'm going to have different segments. And so I'm just picking some random values. Random values centered around 0.5, random values centered around negative 0.5. That's what I have for y1 and y2. And we'll go ahead and we'll plot this. And so to do that, I'm going to take the already established plot P, which is the cosine curve plus the dots. And now I'm going to add segments. Okay, geom underscore segment requires kind of your starting. So we have X and Y, and then you have X end and Y end. Those are the aesthetic attributes required to plot segments. And so I've got X1 goes to X, Y1 goes to Y, X2 goes to X end, Y2 goes to Y end. And the data comes from a different data frame, df underscore segments. There we have that. Okay, and now I plot that. And here's our plot, kind of containing all of the graphic elements from the 3 different data sets. Okay, 3 different data frames, right? We have a data frame for the cosine curve, a data frame for the dots, and the data frame for the segments. And so these are all what can be done. You can combine multiple plots or multiple data frames into a single plot. Okay, that's it for this kind of supplemental video for ggplot. I hope it was helpful, and I hope these slides were helpful as well. All right, have a good day.